Can you see the screen?
Yes.
Why it is taking so long to reply? Can you see the screen? Yes or no?
Yes.
Say immediately. Why I have to ask the question 2 times, 3 times? Okay. So we were regarding force. We were studying force. What is force? A push or a pull that can change the state of rest of a body, that can change the state of motion of a body, which can increase or decrease the speed, or which can change the size or shape of a body. Right? That's what is a force. What is a
Yes.
force? A force is what
A
can
push,
or a pull
a pull,
that
or
can push. Yeah, a pull or a push. A force is a push or a pull.
pull is called force.
No, that is not force. A force is a push or a pull that can change the state of rest, the state of motion, increase or decrease the speed, or change the size and shape of a body. That is force. A force is a push or a pull, that is not force. A force is a push or a pull that can change the state of rest of a body, that can change the state of motion of a body, that can increase or decrease the speed or change the direction of a body, or which can change the size or shape of a body. That is force. Right?
Yes.
Force is a push or a pull, that is not force. Force is a push or a pull that can change the state of rest or motion of a body, increase or decrease the speed of a body, change the direction of a moving body, or change the size and shape of a body. That is force. So, how to measure force? Like you measure. How do you measure length? Length you measure in meters. 1 meter, 2 meters, 3 meters. Right? You
Yes.
measure volume in liters. 1 liter, 5 liters. So, we measure. How do we measure force? Unit of force is 1 Newton. We write capital N, but actually 1 Newton. The symbol is capital N, not small n. Capital N, 1 N, that means 1 Newton. That is the unit of force, 1 Newton. Just like unit of length is 1 meter, unit of volume is 1 liter, unit of mass is 1 kilogram, 1 kg. Similarly, unit of force is 1 Newton. Got it? 1 Newton.
One.
And
Okay.
how do you write Newton? Capital N. 1 Newton, capital N.
Okay.
So, how much is 1 Newton? It is the force required to pick up or lift 100 grams of any substance. If you have 100 grams of anything, haldi powder or some spices, or 100 grams of green chilies, 100-gram packet biscuit, this biscuit, 100 grams. So anything 100 grams, you have to pick it up and put it on the table. So the force needed to pick up this 100 gram, that would be 100 gram thing, that would be 1 Newton. You have 100 grams of anything. It could be a packet of haldi powder, it could be a packet of jeera or dhania, it could be green chilies, it could be biscuit packets, anything. If it is 100 grams, the force needed to pick it up, you have to pick it up and put it on the table. The force you need to pick it up, the force you needed to lift it, that is 1 Newton. Right? Got it?
Got it.
The force you need to pick up 100 grams of any substance. It can be anything. It can be a packet of biscuits, it can be green chilies, it can be candies, it can be ice cream. 100 grams of anything, if you want to pick up, the force you need to pick it up, you have to put it on the table. The force you need to pick up this one is 1 Newton. So 1 Newton is the force required to pick up or lift 100 grams of any substance. That is a force equal to the weight of 100 grams of anything. Right? The weight of this, anything, 100 grams, the weight of this would be called 1 Newton. So weight is a force. The Earth's gravitational pull. What is weight? The pull of gravity. The pull of Earth's gravity is force. So weight is a force. Weight is also a force. So the weight of 100 grams of anything would be 1 Newton. Right? 100 grams is not 1 Newton. The weight of 100 grams is 1 Newton. Don't say 100 grams equal to 1 Newton. 100 grams is a quantity of substance, the quantity of green chilies, the quantity of biscuits. It is the weight of 100 grams that is 1 Newton. Weight is a force. So weight of 100 grams is 1 Newton. That is a force needed to pick up 100 grams of anything. That is 1 Newton. If you are asked to pick it up, how much force you would need? That is 1 Newton. Clear?
Okay.
So the force needed to pick up or lift 100 grams of any substance, that is the weight of 100 grams. The weight of 100 grams of anything, the weight would be 1 Newton force. And weight is a force. Weight is also a force, the force of gravity. So the force due to weight of 100 grams is 1 Newton. 100 grams is not 1 Newton. The weight of 100 grams is 1 Newton. Okay?
Okay.
100 grams will tell you how much substance is there, how much green chili substance, how much biscuit substance, how much haldi powder substance. That is 100 grams. The weight of 100 grams will be 1 Newton. So, weight of 100 grams is equal to a force of 1 Newton. Weight is a force. So 100 grams, the weight is equal to a force of 1 Newton. If you take 1 kg, 1 kilogram of anything, 1 kg potato, 1 kg sugar, 1 kg salt, if you take 1 kg of anything, then that would be equal to 10 newtons. 100 grams, the weight of 100 grams is 1 Newton. The weight of 1 kg, the weight of 1 kilogram. Why that sound is coming? Weight of 1 kg. Weight of 1 kg potatoes, 1 kg sugar, 1 kg salt, 1 kg rice. The weight of 1 kg is 10 newtons. So the weight of 100 grams is 1 Newton. The weight of 1 kg of anything is 10 newtons. Okay?
Okay.
Now this 10 newtons, which is the weight of 1 kg, is also called 1 kilogram force. 1 kgf means kilogram force. Kg is kilogram, kgf is kilogram force. Old name, previously it was called kilogram weight. Kg weight, kilogram weight. Now it is called kilogram force, kgf. So the weight of 1 kg is 1 kgf, that is 10 newtons. Weight of 100 grams is equal to 1 Newton force. Weight of 1 kg of anything is 10 newtons force or 1 kgf force. A force of 1 kgf is equal to a force of 10 newtons, that is equal to a weight of 1 kg. And weight of 100 grams would be 1 Newton. So what is 1 Newton? Weight of 100 grams of anything. And what is 1 kgf? Weight of 1 kg of anything. 1 kg potato, 1 kg sugar, 1 kg of anything. The weight is 1 kgf and also equal to 10 newtons. 1 kgf equal to 10 newtons. Okay?
Okay.
So what is 1 Newton? Weight of 100 grams of anything. Weight of 100 grams of anything. And what is 10 newtons or 1 kgf? Same thing. 1 kgf and 10 newtons are same thing. Weight of 1 kg of anything. 1 kg potato, 1 kg sugar, 1 kg rice. The weight, 1 kg is not 10 newtons. The weight of 1 kg of anything, the weight is equal to 10 newtons or 1 kgf. Okay?
Okay.
So kg is not kgf. Kg is how much potato is there? 1 kg. What is the weight of potatoes? 1 kgf. How much sugar is there? 1 kg. What is the weight of 1 kg sugar? 1 kgf. How much salt is there? 1 kg. The quantity of salt 1 kg. The weight of this salt is 1 kgf. So how much rice is there? 1 kg. Quantity of rice 1 kg. The weight of rice is 1 kgf and equal to 10 newtons. Okay?
Okay.
Now, what will happen if there are two equal and opposite forces? Like this box, this side 100 newtons, this side, opposite side 100 newtons, equal and opposite forces. If there are equal and opposite forces, they cancel out each other, the total effect is 0. 100 newtons acting towards the left and 100 newtons acting towards the right. So 100 newtons to the left, 100 newtons to the right. So both are equal and opposite. The total is 0. So equal and opposite forces cancel each other. So box doesn't move. Box will not move because there are two equal and opposite forces. So two equal and opposite forces will cancel. It is just like you are cancelling plus 5 and minus 5. Plus 5 and minus 5, you cancel, get 0. Plus 10 and minus 10, the effect is 0. Right? So one is regarded as plus 100, the other is regarded as minus 100. So the effect is 0. So two equal and opposite forces cancel each other. So the total effect is 0.
0.
And it can also be 3 or 4. It doesn't have to be 2. It can be 2 or more forces. When they cancel out one another, the net result is 0. They are called balanced. You can have 2 forces, you can have 3 forces, you can have 4, you can have 5, you can have 6. You can have any number of forces, not always 2. Here we have shown 2. You can have 3, you can have 4, you can have 5, you can have 10, you can have 100 different forces. If they cancel out one another and if the total result is 0, then they are called balanced forces. Balanced forces do not move a body at rest. Balanced forces do not change speed or direction. Balanced forces do not do anything. Balanced forces cannot move a body at rest. Balanced forces cannot change the speed. Balanced forces cannot change the direction of a body in motion. Balanced forces means the total effect is 0. So it can be 2 forces or 3 forces or 4 or 5 or 6. When forces cancel out one another and the total result is 0, they are called balanced forces. And the total result will be 0, no effect. No moving the body, no stopping the body, no changing the speed and direction of the body. Balanced forces do not do anything. The total effect is 0. Okay, got it? So when 2 or 3 or 4 forces are balanced, the total effect is 0. They will not move anybody, they will not stop anybody, they will not change the speed or direction, they will do nothing. Because the speed, direction, or other things are changed by unbalanced forces. If forces are balanced, the total result is 0, then they do nothing. They cannot move the body, they cannot change the speed of a moving body, they cannot change the direction of a moving body. So, the total effect is 0 if they are balanced forces. When they are balanced, when they cancel out each other and the total is 0, the net effect is 0. If the total is 0, why so much sound is coming? Don't make. When the total effect is 0, when the total effect is 0, then we call them balanced forces. They cancel out each other and you do not have any effect, right?
Yes.
What is the noise coming? See, the noise is not the background noise. So much noise is coming. So much noise is coming. If there is any TV or any other phone, move to another place. So 2 or more forces cancel out each other and the net result is 0. So equal and opposite forces cancel out each other, total effect 0. So here is the example. In this tug of war, no team wins. Why? Both the teams are exerting equal and opposite forces. The rope doesn't move left or right. This rope will not move in the tug of war. The rope will not move because towards the left 100 newtons, towards the right 100 newtons. Towards the left 100 newtons, towards the right 100 newtons. So they cancel out each other. So net effect 0. No team will win. The rope doesn't move. Got it?
Yes.
You can see the tug of war. Two teams pulling. Can you see the picture?
Yes.
Two teams are pulling. Both are 100 Newton forces and both are equal, but they are opposite in direction. Equal forces in opposite direction cancel out each other. Total effect 0. Got it?
Got it.
A system of several forces. Now here you have three forces. Three forces in this triangle. Three forces. The total effect will be 0. Balanced forces. Here square. There are four forces. Four different forces equal. So the total effect is 0. So not only two, you can have three forces which are balanced. You can have four forces that are balanced. You can have 100 forces that are balanced. It is not always two forces. You can have 3 or 4 or 5 or 6 or 10 forces. But if they cancel out each other, the total effect is 0. They will be called balanced forces. Balanced forces means they will cancel out. The total effect is 0. The combined effect is 0. The combined net effect is also called resultant. The result or resultant, the combined effect, the net effect, the total effect is 0 if they are balanced forces. So three forces which are balanced, total effect 0. Four forces that are balanced, total effect 0. The resultant is 0. The combined total net effect is 0. So not only two forces, you can have 3 or 4 or 5 or 6 forces. They are balanced and their total effect is 0. The resultant is 0. Now, forces acting in same direction get added. See here, two forces are acting in the same direction, not in opposite direction. Here, two men pushing this one, both are exerting force in the same direction. The forces are in the same direction, right? One man 50 newtons, one man 60 newtons, but same direction. Here, one man pulling with 70 newtons, one man pushing with 55 newtons, same direction, not opposite direction, same direction. Then you add them. If they are in same direction, you add. So in this case, the total effect, the resultant or the net effect will be 70 plus 55, 125 newtons. Case 1. Case 2, 50 newtons and 60 newtons acting in the same direction. So add 50 plus 60, 110 newtons. Forces, if they are acting in the same direction, you will add. Okay?
Okay.
Forces acting in the same direction will be added. Forces acting in opposite direction are subtracted. If forces are acting in opposite direction, they are subtracted. So 70 newtons, see, they are acting in opposite direction. One man is pushing to the left and one man is pushing to the right. So you will subtract. When you subtract 70 minus 55, 15 newtons towards the left, which is bigger. Similarly, in this case, both are pulling in opposite direction. So 60 minus 50 equal to 10 newtons towards the right, towards the bigger one. So when forces are in opposite direction, they get subtracted. Right?
Yes.
Forces in the same direction, you add them. Forces in the opposite direction, subtract. If they are in same direction, we will add. But they are opposite direction, we subtract. 70 minus 55. Here, they are in opposite direction, subtract. 60 minus 50. And the final direction is the bigger force. If the bigger force is towards the left, then left. If the bigger force is towards the right, then right. Whichever is bigger. So forces in the same direction, you will add, addition. Forces in opposite direction, you will subtract. Right?
Yes.
Same direction, forces add. Opposite direction, forces subtract. Now, why is the book at rest? If the book is at rest, that means balanced forces. This should be balanced forces. The weight of the book, that is the gravity, is acting downward, and the table is exerting upward force to support it. So the table's upward support acting in upward direction and the weight acting downward direction, they are equal. That is why the book is not moving. The book is not moving because the supporting table, the force is upward, the weight of the book is downward, they cancel each other, so the net effect is zero, that is balanced forces. Why is this at rest? The weight of the ship is acting downwards, the buoyancy force is acting upward, the two are equal and opposite, they cancel each other, balanced forces. Weight of the ship acting downward and the buoyancy is acting upward. So both are equal and opposite, that is why the ship is not going up or down. The boy is moving, but the box is not moving. The boy is pushing, actually. The boy is not moving. The boy is pushing, but the box is not moving. Why? The boy is pushing, that is muscular force, and opposite is a friction. Opposite is a friction. So both are equal and opposite, and the box does not move. So here the book is not moving. Why? The gravity, the weight of the book down, and the supporting force of the table up. Equal and opposite, balanced forces, total effect zero. Here, second case, weight of the ship downwards, gravity downwards. Weight means gravity, and the buoyancy of the water upwards. Equal and opposite, balanced forces, ship does not go up or down. The boy is pushing, muscular force in one direction. The boy is pushing, muscular force in one direction, friction in the opposite direction, so the box does not move. They are called balanced forces. The total effect is zero. The weight downwards is equal to the force upward, or the force of push is equal to the friction. Balanced forces, they will cancel out each other, no movement. So they are at rest. They are balanced forces, two equal and opposite forces. Gravity or weight downwards and buoyancy or the supporting table upwards. The boy is pushing to the right, the friction is acting towards the left. Two equal and opposite forces, no motion, the body is at rest. They are called balanced forces. Okay?
Okay.
So what do you mean by balanced forces? When the total effect is zero, the forces cancel out each other. Like our equal forces acting in opposite direction. They cancel out each other, balanced forces. So it will not go up or down, it will not go left or right. So the box will not move if the push is equal to friction. If the boy is pushing, if the push and the friction are equal, the box will not move because they will be balanced forces. They will cancel out each other, total effect zero. If push is greater than friction, push is more than friction, then the box will move. If the push is more than friction, then the box will move. If the push is equal to friction, the box will not move. If the push and friction are equal, what you are getting? Balanced forces, equal and opposite forces, no motion. If the push is bigger than friction, then you will get motion. It should be unbalanced forces, right?
Yes.
So an unbalanced force always changes the state of rest or state of motion of a body. It should be unbalanced force. If it is balanced force, then the thing will not move. If the pushing is equal to friction, if the downward weight is equal to buoyancy of water, if the forces are equal, it will not move. The body will not move. You need an unbalanced force to move the body or to stop the body. So only an unbalanced force changes the state of rest or motion of a body. A balanced force does not change the state of rest or state of motion of a body. If force brings about no change, it is because it is a system of balanced forces. If the box is not moving, it is balanced forces, a system of balanced forces. That is net effect 0. If a small child can't push a heavy box, it is because his push is opposed by friction. The child is pushing and the friction is acting in opposite direction. That's why the box is not moving. If a body does not roll down a slope because friction is acting upward, gravity is acting downward. If forces are balanced, the body does not change state of rest or state of motion. If the forces are unbalanced, if the system is unbalanced, then the body will move or the body will stop moving or the body will change the speed or direction. So yeah, you can see the desk is sloping. The desk is sloping. The desk is not straight or horizontal. It is sloping. But the book does not slide down. The book should slide down. The book is not sliding down. Why? Opposing friction. Downward motion is equal to opposing friction. Balanced forces, so the book does not move. You are able to walk down a slope. You don't fall down. Why? Friction. The downward slide is equal to upward friction. So you don't slide down. That's why you are able to walk here. So there is the boy writing on a sloping table. The book does not slide down because of friction. The downward sliding force is equal to opposite friction. Here, the person is able to walk down a slope. They don't fall down because the downward sliding force is equal to opposite friction. Balanced forces. When they are balanced forces, the net effect is 0 and you don't fall down. Now, up to this clear?
Yes.
So what we discussed, the force, it is 1 Newton equal to the weight of 100 grams. If you have 1 kg of anything, 1 kg of potatoes or 1 kg of sugar or whatever it is, that is 10 newtons or 1 kg of. If two forces are equal and opposite, they will cancel out each other, net effect 0. They are called balanced forces. Only unbalanced forces can move a body or stop a body. And equal forces, if they act in opposite direction, they will be balanced 0. And two forces in same direction, you add them. 10 newtons and 15 newtons, add them, 10 plus 15. If they are in opposite direction, subtract. 30 and 25, opposite direction, 30 minus 25, 5 newtons. So opposite direction, forces you subtract, same direction, forces you add. Right?
Yes.
Now aeroplanes, when flying, during flight, means aeroplane is flying, it will face friction with air. Air is there, so air will rub it. So air friction. Just like you have friction on the ground, air will also give friction. So aeroplanes flying will have friction. A fish swimming in water will have friction with water. A fish is swimming, friction with water. An aeroplane is flying, friction with air. So this air resistance for aeroplanes when they are flying, that is called air resistance or drag. This friction, it is a friction actually, but we call it drag. Air resistance or drag. Friction with air, when a bird is flying or when an airplane is flying, the friction with air is called air resistance or drag. Similarly, when a fish is swimming, it is water resistance. Drag can be minimized. How to make the drag very small? By making the outline evenly smooth without sharp bends. See, no sharp bending, even smooth outline. This shape is called streamlined. The shape you can see for the aeroplane and the fish, it is called streamlined. Evenly smooth outline, no sharp bends. Birds and fishes have streamlined bodies. Aeroplane will always have streamlined body. Why? To minimize drag. to minimize air friction, to minimize air resistance, to minimize drag. So fishes and aeroplanes will have streamlined bodies. That means these shapes are evenly smooth without sharp bends so as to minimize the friction. Okay?
Okay.
There is a streamlined shape. Streamlined shape means evenly smooth without sharp bends. The outline should be smooth without sharp bends. That is a streamlined shape. That means the friction with water will be very little. The friction with air will also be very little. So the speed will be high. So there is a streamlined meaning, streamlined word. The word streamlined means smooth outline without sharp bends so that you have minimum air friction, minimum drag or minimum water resistance. So minimum friction for streamlined bodies, aeroplane, fishes and birds. Right?
Okay.
Aeroplane, fish, bird, streamlined bodies to minimize friction. The meaning of streamline, evenly smooth without sharp bends, like this. So there is a summary. Force is measured in Newton or kgf. The old name of kgf was kgwt. The new name is kgf, kilogram force. It is called kilogram force. It is measured in Newton or kilogram force. 1 Newton equal to weight of 100 gram of anything. Don't say 1 Newton equal to 100 gram. 100 gram is quantity, 1 Newton is weight. Weight means the Earth's gravity, pull. The Earth is pulling, gravity. So 100 gram is quantity, the weight of this quantity is 1 Newton. And 10 Newtons or 1 kgf is the weight of 1 kilogram of anything. 1 kg potatoes, 1 kg sugar, 1 kg salt. That is quantity. The weight of that 1 kg potato will be 10 Newtons. 1 kg is not weight. 1 kg is a quantity and the weight of that would be equal to 10 Newtons. Weight is a force. Kg is a quantity. Kg is not force. Kg is a quantity and kg of a Newton is a force. When you say Newton, it is a force. When you say kgf, it is a force. When you say kg, it is a quantity. Right?
Yes.
So 100 grams of anything, the weight is 1 Newton. 1 kg of anything, the weight is 10 Newtons or the weight is 1 kgf. Balanced forces cancel out each other, means total effect 0. Balanced forces means equal and opposite. They cancel out each other, total 0, effect 0. Forces in same direction, add them. 10 newtons and 20 newtons, same direction, add 10 plus 20. Forces in opposite direction, subtract. 20 newtons and 15 newtons, 20 minus 15 equal to 5. Forces in opposite direction, subtract. A body moves only if the push or the pull is greater than friction. If the push or the pull is equal to friction, the body will not move. The body will move only if the push or pull is greater than friction. Right? A body will move only if push or pull, the force of push or the force of pull is more than friction. If the push or pull is equal to friction, the body will not move. The body will move only if there is unbalanced forces. Push or pull is not equal to friction. Pull or push is greater than friction. Only then the body will move. Only unbalanced forces can move the body. Okay? Got it?
Got it.
Okay. So that is force.